Good morning all. So in today's class, we'll move on to the last section of module 1. So that is on rank and classification of a second order curve. So as you have seen, the general second order curve is of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. And we need to so we have found what is delta. So delta was the determinant of the matrix AHG, then HBF, GFC. So we have seen this matrix already. For this matrix, you can find out the rank of the matrix. You have already learned how to find the rank of a matrix. The rank of this matrix is defined as the rank of a second order curve. So the rank of second order curve is the rank of the matrix AHG, HBF, GFC. Now, depending on the rank of this matrix, your second order curve can be classified into a conic or some other curve. Okay. അപ്പം നമുക്ക് വരുന്ന curves ഒന്നെങ്കിൽ it can be circle, parabola, ellipse, hyperbola, or it can be pair of straight lines, or it can be points. So those are the possible types of curves you are going to get. Now, depending on the value of rank, the second order curve can be mainly classified into two types. Okay. First is second order curve can be non-singular. ഒന്നെങ്കിൽ non-singular അല്ലെങ്കിൽ it is called non-degenerate and singular. So those are the non-singular or non-degenerate and then singular or degenerate. For second order curve can be of these two types. So it can be non-singular or non-degenerate and can be of the second type, singular and degenerate. And it is said to be non-singular or non-degenerate if the rank is equal to 3. So rank 3 ആണെങ്കിൽ it is called as non-singular or non-degenerate. So we say that a matrix is non-singular if its determinant is not equal to 0. That means the rank must be equal to the എത്ര റോസ് ഉണ്ടോ അതിനോട് ഈക്വൽ ആയിരിക്കണം റാങ്ക്. ഓക്കെ. And we say that a second order curve is singular or degenerate if its rank is 2 or 1 respectively. Okay, so that is how we define singular or degenerate second order curve. So provided the rank is 2 or 1, we call the curve to be singular or degenerate. Now for conic, you have seen delta എടുക്കുമ്പോൾ delta will be this determinant. So we have seen delta must be not equal to 0. So this determinant will be always not equal to 0 in the case of a conic. So that means the rank will be equal to 3 in that case. So circle, parabola and ellipse and a hyperbola. That means whenever you get a conic, your matrix will be non-singular. So the rank is equal to 3 in that case. Now, degenerate avuna case, you can get a point ellipse. Okay, അതായത് x square by k 0 വരുന്ന കേസാണ് നമ്മൾ എലിപ്സിന്റെ ഇക്വേഷനിൽ കണ്ടതാണ്. എക്സ് സ്ക്വയർ ബൈ എ സ്ക്വയർ പ്ലസ് വൈ സ്ക്വയർ ബൈ ബി സ്ക്വയർ ഈക്വൽ ടു 0 വരുന്ന കേസാണ് പോയിന്റ് എലിപ്സ്. സോ that means you are obtaining a point there. So a point ellipse അല്ലെങ്കിൽ a pair of intersecting lines, a pair of parallel lines and a pair of coincident lines. So these are the cases where you obtain a rank which is not equal to 3. ഇപ്പം റാങ്ക് 2 അല്ലെങ്കിൽ 1 ആയിരിക്കും. So in that case we get singular or degenerate second order curve. So these are called singular or degenerate second order curve. So it can be point ellipse, a pair of intersecting lines, a pair of parallel lines, and a pair of coincident lines. For coincident lines, the rank will be equal to 1, and for the other cases, the rank will be equal to 2. So, this is the idea we have seen now. So, the general second degree equation represents, so you get a degenerate conic if delta is equal to 0. That means the determinant singular ആയിരിക്കും, that means it will be 0. And we obtain a non-degenerate conic if delta is not equal to 0. That means rank must be equal to 3. And non-degenerate conics, as we have seen earlier, that can be classified into 3 types depending on the value of d. So when d is greater than 0, you'll get an ellipse. So when d is equal to 0, it is parabolic, and when d is less than 0, it is hyperbolic. Now, circle is obtained as a special case of ellipse when you have a and b both are equal. Okay. So circle day condition അത് തന്നെയാണ്. So d greater than 0 ആയിരിക്കണം. So when you find out the equation, in the equation a must be equal to the major axis and minor axis must be equal. So this is a table which gives the entire classification. Okay, അപ്പം റാങ്ക് 3 വരുന്ന കേസിൽ നമുക്ക് വരുന്ന പല ക്ലാസിഫിക്കേഷൻസ് ആണിത്. So when you have a canonical form, ഇപ്പം ellipse വരുന്ന കേസ് rank is 3, it is non-singular. So the condition for identifying ellipse is delta must be less than 0 and d must be greater than 0. And for circle, delta greater than 0, d greater than 0. So here both alpha and beta are equal. You get an imaginary ellipse when on the right side you have -1. So again, for imaginary ellipse, the rank is 3, so it is non-singular. So delta is greater than 0 and d is greater than 0. D less than 0 വരുന്ന കേസിലാണ് delta not equal to 0 and d less than 0. There you will get a hyperbola. So when delta greater than 0 and d less than 0, you will get a hyperbola. So rank is 3, it is non-singular. Delta less than 0, delta d less than 0, we will get a conjugate hyperbola. So that is the case for hyperbola. In a parabola, delta is not equal to 0, so delta can be positive and negative, but d must be equal to 0. So that is the equation of parabola. So again, for parabola, rank is equal to 3. Now, these are the cases where delta is, so these are the cases where delta is not equal to 0. Delta not equal to 0 ആകുമ്പോൾ നമുക്ക് conic ആയിരിക്കും കിട്ടുക. Let us look at the different classifications when delta is equal to 0. Okay. So when delta is equal to 0 and d greater than 0, we will get an equation of the form ax square plus by square equal to 0. So that is a pair of imaginary lines or a point ellipse. So here you will get a pair of imaginary lines. അപ്പോൾ നമ്മൾ x എടുക്കുമ്പോൾ x equal to, you will get plus or minus root of minus b by a y. So that will be a pair of imaginary lines. അല്ലെങ്കിൽ if you want real values, only the point 0, 0 will satisfy this equation. So it will be a pair of imaginary lines or a point ellipse. And here the rank will be 2 singular ആയിരിക്കും, കാരണം delta equal to 0 ആണ്. So the rank is 2 in this case. When delta is equal to 0 and d less than 0, we are getting a pair of intersecting lines, so which is y square minus k square x square equal to 0. Again, the rank is 2, it is singular. And when delta is 0 and d is 0, we get pair of parallel lines. And again, the rank is 2 and it is singular. And when delta is 0, d is 0, and if you have y square equal to 0 and x square equal to 0, so if you get this equation, that denotes a pair of coincident lines. So for pair of coincident lines, your rank will be equal to 1, it will be singular. So those are the different values taken by the rank for a second order curve, and these are the uh, different types of curves you are getting. So when rank is 3, those are non-degenerate curves, and these curves, these pair of straight lines allengi points, they are called degenerate curves. Look at an example. So here we have delta equal to determinant of 4. Okay, let us write A is 4, B is 1, H is 2, G is minus 2, and H is minus 1, and C is equal to minus 1. So delta will be 4, and we'll have 2 here, then minus 2, then B is 1, C is minus 1. So here you will have, sorry, this is F divided by minus 1, minus 1. So here you can see that the first row is a multiple of the second one. So therefore you will get, so rank will be, okay, delta will be equal to 0. Now let us look at the rank. So when you take this matrix 4, 2, minus 2, 2, 1, minus 1, minus 2, minus 1, minus 1. So that will be row equivalent to the first row, and R1 0 come. So that will be 0, 0, 0. So you will get 2, 1, minus 1. Then you take, so I have done here, R1 goes to minus 2, R2 plus R1, then take R3 goes to R3 plus R2. So that will give 0, 0, minus 2. So you can see that the rank will be equal to 2. So therefore you have delta equal to 0, and the rank is equal to 2. So therefore we get a singular. So this is a singular or degenerate conic. So that is how we use rank to determine what type of conic it is.